started. Okay, here we are. Again, what right, we had to pass a certain test, and I'll give you part of the test, see if you can remember. Do you, any of you remember the test? You knew it about a week and a half ago.
Did it have like a bunch of NPs?
Yes, it did.
Additions?
It had a bunch of NPs.
Oh, was it?
It's
was
coming, it's
NP
coming.
NP1 plus NP2? No.
Yep, NP, I'll give you part of it. NP had to be greater than something, and N times 1 minus P had to be greater than something. What was the number?
10.
10. All right.
We had the
All right. So, greater
Didn't she
than.
ask if it was the 10 thing?
I added an N.
So, over here we need to, in order to use the standard deviation rule for P hat, we have to prove this. All right. Over here, to use chart A, we have to prove this. So let's do an example. How about the one on your paper? So turn in the back where it says check your understanding and see, could you read it to me, Elena? Check your understanding on the back. It starts out something about 75%.
Okay. About 75% of young adult internet users ages 18 and 29 watch online videos. Suppose that...
All right, wait a minute. Let me take some notes. Hold on. So you said 75% young adults. Go ahead. Over what? What do they do?
Internet users
All right.
ages 18 to 29
All right. Keep going.
watch online video. Suppose that a sample survey contacts an SRS of 1,000 young adults.
All right. So that's our sample size. Oh wait, we use little n for our sample size. So you said it was what?
Sample survey 1,000 adults.
1,000. Okay. All right. So next, keep on, and I'll see if
Okay.
there's anything else.
Calculates the proportion of p hat in the sample who watch online video.
Okay. So we're going to find p hat, and that's the proportion who watch the video. So proportion is watchers. All right. So Caleb, we're on the example in the back of this handout. Check your understanding. All right, the first thing it asks for, Allie, what's number 1? What do they ask for?
What is the mean of the sampling distribution of
All right.
p hat?
All right, now you should be able to answer that. Can you, Allie? There's not a big, it's not a very big calculation because look up here.
It'd be 0.75.
Right, so the actual mean of the p hat is p. So number 1 is 0.75. All right, Bailey, read part 2, number 2.
Find the standard deviation of the sampling distribution of p hat.
Okay.
Check that the 10% condition is met.
All right, so we want the standard deviation of p hat, but first we have to perform the test. So, what is the sample size again, Elena?
1,000.
All right, so 100 times n would be 1,000 times 10, which is 10,000. Are there more young adults in that age group than 10,000?
Yes.
There are. So we checked it off. So at least mentally check it off before you jump into using the standard deviation of p hat.
Wait. Okay, hold on.
So n
It would
is
be-
greater than 10n. N is the number of young adults, and it's greater than 10 times 1,000. Check. There are more than 10,000 young adults. There's millions of young adults. All right. All right, Bailey, help me with the standard deviation. Now that I have checked off the requirements to finding the standard deviation,
Now you have to use the equation, so you do the square root
of
0.75 times 0.25 divided by 1,000.
all right, tippy tap. Let me see what that is.
Bless you.
Thank you.
1.08 square root.
Point what?
0.0137.
Okay, that's correct. All right, now we have to check for normality. So, Caleb, do you remember from last chapter how we check and see if a distribution can be used for normal? There were two things we had to check. NP had to be greater than some number, and n times 1 minus p had to be greater than some number. Do you remember from last chapter what that number was?
No.
So this is for normal, checking for a normal distribution. Do you recall? We had just had a test about a week and a half ago. You do it then, but it fades quickly, doesn't it?
I don't know if I did. I don't know if I knew it then.
Pardon?
I don't think I knew it then.
Oh, I bet you did. All right, it had to be, the test for being normal was these both had to be greater than or equal to 10. So let's test it in this case. Well, number 3, can we use the normal distribution for this? So is NP greater than or equal to 10? So N is 1,000. P is 0.75. Is that greater than 10? I would say so. I don't even have to do the number to see that it's like 7,500 or something. And what about 1,000 times 1 minus P, which is 0.25? Is that greater than 10? I'd say it is. So very quickly I can glance at those and see that it does qualify to use the normal distribution methods. Lastly, they ask us to do what? Elena, read 4.
If the sample size were 9,000 rather than 1,000, how would this change the sampling distribution that we had?
All right, what do you have to say about that, Elena? What happens when, if the sample were 9,000?
The spread would probably be a lot smaller.
Right, because we read up here, as the sample gets bigger, the standard deviation gets smaller. That's right. And if you actually change this number to a 9,000, would it not create a smaller number? Okay, very good. All right, we finished one more to go, so read it to us. This is where we're going to stay here and figure out how to use this normal information. So I'll leave that up. Allie, read about the polling organization.
A polling organization asks an SRS of 1,500 first-year college students.
Okay, wait a second. N equals 1,500,
Do you
okay?
want to sit here?
And those are freshmen. All right, go ahead.
Okay. How far away their home is. Suppose that 35% of all first-year students actually attend college within 50 miles of home.
All right, so is that P or P hat?
That is P.
It is. That's the actual proportion. So we're expecting, if the question is, do you live within 50 miles from home, 35.35 or 35% should say yes. All right, so go ahead, Allie.
What is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true value?
All right, so if we're going to be within 2 percentage points of 0.35, we could be as high as 0.37 or as low as 0.33. All right, so does that make, when they say within 2, make sure you go up and you go down. So let's go ahead and look at that. So I'm going to write it in proportion, in probability lingo. What's the probability that, how shall I write it? Let's say the probability that 0.33 is less than P hat, which is less than or equal to 0.35. So,
Not 0.37?
I'm sorry?
Not 0.37?
Oh, 7, you're right. Sorry. Okay, thank you. All right, with that then, can we use chart A are we allowed to use chart A in this scenario? So, over to you, Bailey. How do I know if I can use this and call it approximately normal?
Use 0.35 times
That's why I left this up here.
1500.
Yeah, so is this number times this number greater than 10? Yeah. What about this number times what? What number would I need for this part?
0.65.
Right, 0.1 minus 0.35 is 0.65. Is that number greater than 10?
Yeah.
Okay, onward then. All
Has it
right.
been long enough that we need to stop the video?
We already did.
Oh, okay.
Something
Alright.
inside it, but it might be time to do that again.
Really?
Actually, yeah.
Well,
I
let's
think we
finish
have like
one
5
more.
more
Let's finish
minutes.
this and we'll shut it down. All right, so we had to use chart A. We can use, this is normal, so we can use chart A. What do we do with these numbers, Kayla? Before we can use chart A, what do I have to do with 0.37?
Z-score?
Yes, so would you remind me how to get a z-score from 0.37,
Subtract it from the mean,
right? And divide by?
standard deviation.
All right. So what is that, Elena? What
Um,
is the mean of this, in this problem, what's the mean of p hat?
The proportion.
Right, which it is,
Um,
what number is it?
1500.
No, that's the sample mean. I mean, that's the sample size. P is this number,
Batteries are low.
right here. All right, so
0.35.
0.35,
Same for calculator or same for bot?
all right.
Super batteries are
So,
low.
Allie, where do I go to
I-
get the
But
standard
you could use
deviation
my
of
batteries
p
are low,
hat?
too.
You
Oh, yeah,
go
me.
to the
Not your
equation
calculator.
thingy
No.
All right.
and then
All right,
That's what I thought.
tippy tap, everyone. I need the standard deviation of p hat. My hat turned into something else here. Okay, look like a haystack. All right, so I need you to throw the numbers from our sample. N is 1500, p is 0.35, 1 minus p is 0.65. Square root it.
how do you get back to where?
It's very small.
Is it, what is it,
Or I
Caleb?
did I do wrong? I got 1.5e negative 4.
You take the square root of that.
Square
And
root.
you
Square
get
root.
0.012.
Oh, 1, 2, 3.
0.0123?
302.
Yeah.
Okay. Did you get that, Caleb?
Yeah.
0.0123. All right, now I need a z-score. So I had to remember this stuff from this box in order to get the z-score because I needed the mean and the standard deviation of p hat.
1.626.
Why does it do that? This class.
And it rings
it's not even
every
the same
time. I
time.
teach physics here, it rings. So,
Does it ring in the other rooms?
Who is calling us? I think it's a ghost.
Why doesn't it ring in the other
I
rooms?
think it is.
I don't know.
The room is
I didn't-
haunted, and you don't even care.
I think it's
All right.
Krampus.
chart A, I
It's
need a
not-
chart A, 1.63. Look it up, look it up, look it up.
Oh, 1.63.
Oh right, yeah, that's me.
That's not the right thing.
Okay. 1.9484.
0.9484, I'll take it. All right, what else do we
Sounds like a
have to
number.
do? Then,
The opposite.
all right, so we have to do
It would be
Z-score.
0.9474.
Yeah!
0.33
I don't know.
minus 0.35 over
0.947.
0.0123,
It's 0.1.
negative 1.63. Z, I need an A chart for that.
What's the negative?
Got it? Thank you, Ally girl.
Negative 1.6.
Negative 1.6.
0.0516.
0.0516.
It's,
All
they
right,
need to put
so what do I do with these
1.63.
two numbers as statisticians?
Allie.
Caleb, what do I do with these two numbers?
Subtract them.
Right, and what do we get?
9484 minus 0516. 0.8968.
All right, so we have decided that about 90% of all the SRSs of size 1500 will have